All right, let's get into it. Today, we're not just going to run through another safety checklist. Nope, we're going to go a little deeper. We're going to talk about building a real intuition for electrical safety, a way of thinking that goes way beyond just memorizing the rules.
I mean, it's a frustrating question, right? As professionals, we see the same non-compliant setups, the same vulnerable installations, and the same defects popping up on audits and inspections year after year. So what gives? Is it just that people don't know the rules? Or is there something bigger going on here?
And that's exactly what this is all about. Look, the goal isn't to be able to recite clause numbers from memory. It's to really get the why behind those rules. Because once you understand those core principles, you start seeing the risks before they turn into defects. You start building installations that aren't just compliant on paper, but are genuinely, truly robust. Okay, so let's dive into the first principle. And it's probably the most fundamental one of all. I want you to think of it like physical armor for our electrical systems. It's all about protecting them from the real physical world.
We call it mechanical protection, but, it's so much more than just sticking a cable in a pipe. It's a whole mindset. It's having the foresight to think about all the physical stress an installation might face. Could be anything from a shovel on a job site to constant vibration from machinery, or even just years of sun exposure. This is the shield that actually guarantees it's going to last.
A great example of this is how we handle consumer mains on a construction site. It's all about layers of defense. First up, you've got the strategic route. You're placing those cables well away from any high traffic areas. Then you've got your heavy-duty conduit. But where it's most vulnerable, say coming out of the ground, that's where you add some serious metallic shielding. And finally, you make sure that the enclosure, the switchboard itself, is rock solid and protected. See? It's a complete system, a full suit of armor. All right, but what happens when new tech comes into the picture? The core safety principles, they don't change, but how we apply them has to evolve. And that's especially true with the rise of things like multi-mode inverters. You see, adding an inverter isn't just like swapping out one appliance for another. It fundamentally changes the entire circuit. Think about it. A simple AC circuit has a nice, predictable path for a fault to take. But a system with an inverter? Whoa. Now you've got DC components, you've got multiple potential sources of power. This creates these really complex fault paths that your standard protection might not even be able to see, and that can introduce all new touch voltage risks.
And it makes sense, right? As our systems get more sophisticated, blending AC and DC, our protective devices have to get smarter too. I mean, just think about it. Nearly every modern appliance you own, from a computer to a washing machine, has a switch mode power supply that's using DC. That's exactly where something like a Type A RCD becomes crucial. It's specifically designed to pick up on the kinds of DC leakage currents these new electronics can create, faults that an older RCD might be totally blind to. Simply put, modern tech requires modern protection.
Okay, let's switch gears a bit. Let's talk about what happens when these principles get missed. We're going to look at some common defects, but not just as a laundry list of failures. We're going to look at them as clues. Clues that tell us a story about what's really going on with an installation.
So when inspectors and auditors keep flagging the same kinds of issues over and over again, what's the real message there? Are these just simple mistakes? Or are these defects actually symptoms of a deeper misunderstanding of those core principles we've been talking about?
Well, when you look at the data on common defects, some really clear patterns start to show up. You see gaps in the earthing system. That's our fundamental safety net. You see incomplete RCD protection, which leaves people totally exposed. You see vulnerable cabling, which is a total failure of that physical armor principle. And of course, you see poor terminations and unsafe access to switchboards. These aren't just random one-off mistakes. They're failures in the absolute foundational concepts of electrical safety. So the big question is, how do we get ahead of this? How do we move from just reacting to defects to proactively preventing them in the first place? Well, it really comes down to building the right habits and adopting the right mindset every single day on the job.
And let's talk about one of the most hazardous places an electrician can find themselves, the ceiling space. This is not just another work area, folks. This is a high-risk zone, and it demands a whole different level of caution before you even think about starting.
So what makes them so darn dangerous? Well, you've got hidden hazards absolutely everywhere. You could have brittle old insulation, wiring that's been chewed by vermin, maybe some illegal DIY work from years ago, and up there, everything can become a conductor. The ducting, the pipes, the metal framing itself. And on top of all that, it's a confined space. It's hard to get out of in a hurry if something goes wrong. It's basically a perfect storm of electrical risk.
And because of all those risks, this pre-start process is completely non-negotiable. It is not enough to just flick a switch. You have to assess every single potential source of supply in that area. Then you isolate it at the main switchboard. You physically lock it out and you tag it so nobody can accidentally re-energize it. And then, the final, most critical step, you have to test and prove that the circuit is dead before you touch anything. Every step, every single time. This proactive mindset, it goes way beyond just isolation. It's really about developing what I like to call an inspector's eye on every single job. So don't just focus on the one power point you're there to install. Take a look at the whole system. Give that enclosure a push. Is it really secure? Give every connection a gentle tug. Is it terminated properly? You gotta step back and ask the bigger questions. Is the switchboard getting enough ventilation for the load it's carrying? Is that outdoor fitting really rated for direct sun and rain? You need to think about the future, too. Is this installation going to stand up to its environment in 5 or 10 years? That kind of professional curiosity is what separates a good installation from a truly great one.
Okay, so when you put it all together, all of these habits and principles, they combine to form a professional philosophy, a safety mindset that just becomes second nature.
Because at the end of the day, electrical safety isn't some box-ticking exercise. It's not about being afraid of a defect notice. It's a positive goal. It's about taking pride in your work, building things that are made to last, and really championing the standards of our trade with foresight and excellence.
And just as a final note, remember that this is all about helping you build that intuition. It's for informational purposes only, and it's definitely not a formal compliance determination. You should always refer to the latest standards and regulations for any specific requirements. So I'll leave you with this question. On your very next job this week, what's one principle we talked about today? Maybe it's layering that physical armor, or double-checking the RCDs, or using that inspector's eye. What's one thing you can apply to make your work not just compliant, but genuinely, truly safe and robust for the long haul?